So all we got is 8 people, huh? What's the deal? What is the deal? It's time to remind them. Okay. You are late. Like that. All right. Hopefully some people get rolling. All right. So, amigas, how you guys feeling? You believe that AC is almost over?
Not really.
Believe it, sister. It flies by. It's a fun class, but it's a lot of stuff and it's condensed and it's compact and it gets slammed out. So we got this week. The good news though, this week is going to be intense diag. So we'll be doing a lot of diagnostic type of stuff. And I think it'll help you make a lot of sense of what we've covered. And I think stuff will be clicking for you. So this week, a lot of stuff starts clicking. But in the meantime, I'm not going to wait for everybody. We're going to start chipping away. So show what we got left. It's officially 5:31. So we're cleared to start as of 1 minute ago. Okay. So we made it through HVAC theory and operation. We made it through inspection and servicing. We made it through service and repair, and that was where the bulk of the work was. Then we just more recently made it through manual temperature control, and we did start to talk about automatic temperature control. And that's actually part of what we're going to cover today. So there's a packet for that one. I feel like you guys will probably not have a tough time understanding the ATC, automatic temperature control. And there's a couple different variations of that, but it shouldn't be all that tough.
Mr. Kelly,
Yep.
the automatic, that's more so like with like Siennas. I mean more like Camrys, right? Or no, because they have the scroll.
Any system that you can set the temperature on and then it'll adjust. So if you set any of them that you can actually like see the number on, that's automatic.
Okay.
So all those vehicles offer automatic temperature control. They may not be on the base models, but they do have them. And then we're going to jump more into a little bit more about the heating and also start to tie that into hybrid. And then for the rest of the week, we're going to be doing some stuff with auxiliary systems, and a lot of AC diag is going to be the whole rest of the week, which will be pretty fun. So that's the jam. And I've even got the simulator, which is really cool, some diagnostic scenarios, some different ways to do diag virtually in addition to the diagnosis that we're going to do in person this week. So usually should be some pretty cool stuff. I actually don't remember this. Let me click on this real quick. Oh yeah, this is a diag. So everybody's going to get to do a diag. I remember that one. Okay, now what I did was a few years previously, we did the A7 prep. So I did put a link to that previously recorded video. I intend to do that on the last Monday. So don't feel like you need to watch this, but if for some reason you're feeling like you're going to benefit from it, you can. And then let's jump into getting an idea of how the diag is going to be and how the ASE is going to be. And then also there's some animations that you should be able to reference. Shoo, let's go with right here. There should be, okay, this version will not have the answers, and that's on purpose. So what I'm actually going to do is pull it up from off screen, and let's just do a little bit of a sample Few questions. Just to get some idea of what we got left to cover to be ready. So here it comes right now. Okay, so this is the winner. Whoops, maximized on the wrong screen. All right, so we've got HVAC and engine cooling system service diagram repair, the slight majority of the test. Refrigeration system component diagnosis and repair, 10 questions. And operating systems and related controls diagnosis and repair, 19. That's a little bit hard to define what that is, but this may be refrigerant is blowing warm, the vehicle heat is blowing cool, various diagnostic scenarios. This one is probably more gonna be if you have a condenser that's a problem. What type of problems would condensers have? Maybe they're restricted by airflow due to bugs and debris type of stuff. This is probably going to be a lot of things with compressor. So if we had, now that we've all taken compressors apart, did anyone see reed valves in their compressor? Do you guys remember that? Reed valves. So the reed valve would allow flow outward if it's an exhaust reed valve, but it would block flow inward. If it's an intake reed valve, it'll allow flow inward, but block flow outward. If an inlet reed valve is faulty, the inlet reed valve should suck from the low side and push to the high side. But if the reed is faulty, it would actually suck from the low side and blow back into the low side because of a bad reed valve. What do you think that would cause on your gauges, high and low?
Both low, right?
More specific than that. Okay, so I'm gonna give you a little bit. If the compressor is sucking in and then kind of like blow by almost back out the inlet valve, I agree the high side is not going to be that high. But the low side wouldn't get lower. I think the low side wouldn't be as low because it's not drawing the low side down. It's drawing the low side down and then kicking it back out, which is putting it back up. But more specific than the high side being low and the low side being high, you're going to be able to visually see something on these gauges. It's sucking in, pushing out, sucking in, pushing out. It should only be sucking in and blocking, pushing out. So what do you see the needle doing?
Oh, it's flickering back and forth.
The needle will be doing this.
Is that like there's air in the system?
Kind of. The air in the system is different. The air in the system would be on the high side. It might be experiencing a psh, psh, psh. But on the low side, if it's got an inlet reed valve bad, the low side is getting sucked down and then spit back out and sucked down and spit back out. So the low side needle is going to do more of a predictable oscillation. When there's air in the system, that would be affecting the high side because the air has moisture. And when the air has moisture and it gets to the high side, it boils the moisture. Rather than being little droplets of moisture, it becomes a big gaseous vapor. So it makes this high side false pressure, but it would be kind of erratic. This would be the low side needle is oscillating really consistently because of a bad reed valve. That's an example of component diagnosis, specifically the compressor component. And then operating systems and related controls, that's probably gonna be more things like blower resistors, doors, blower motor, these types of things. So it's a little bit hard to predict what's on this one. Here are all the items copy and pasted from ASE that you need to know how to do. And then let's jump into some of my notes. Read wiring diagrams 100%. In other words, there's going to be diagrams. Predict voltage drops and available voltage 100%. Symptoms of open shorts, high resistance. parentheses, dim or slow. Why do you think I say dim or slow right there? What do you think I'm talking about?
When there's multiple options of speeds on the fan and there's only one speed.
All right, so like, for example, if it's a blower motor, it's not going to be dim due to resistance. A light bulb would be dim due to resistance. What would a motor be due to resistance?
Slow.
Exactly. So just understand those. Blower resistors, switches, diagrams, computer inputs and outputs. That's today's topic. Temperature sensors, thermistors, high pressure, low pressure switches, CAN network, little bit about how to use scan tool, verify inputs, things like that. Automatic temperature control stuff. That's today's topic. For heating system, heater core, radiator, coolant flow valve, which we've talked about a few times, coolant pressure, recovery tank, radiator cap, thermostat, electrolysis, cooling fan, AC system, all the components, the compressor, what happens with the clutch when it seizes, when it's not making enough pressure, etc., condenser, evaporator, receiver dryer, all the symptoms of if these have problems, types of oils, when to add oil, how much oil to add, how to find leaks, how to run the identifier, what the vacuum pump does, what type of numbers should it pull. Oh, there's some stuff on pressures, and I've been trying to listen as carefully as I can. This test is not a test of 30 pressure gauge questions. There may be 4 or 5. So pressure gauges is important, but it's not the majority of the test. HVAC airflow, stuff with boxes, actuators, doors, these types of things. So let's go with, there we go. How about this one? 40. This one does happen to be gauges. Vehicle comes in for AC, blows warm. High and low pressures are as shown. So the low is about 28. The high is about 175. This won't tell you the ambient temperatures. It's going to be approximate. Anybody have any thoughts? Let's eliminate. Anybody have anything we can eliminate?
The TXV is stuck open.
If the TXV is stuck open, what would we anticipate the pressures to be?
Equal.
More similar, yeah, close to equal. So I agree, let's eliminate D. In fact, I can do this. Let's eliminate D. Anything else we can eliminate?
B.
I agree, it's not overcharged. If it was overcharged, what would we have?
They will both be high.
High and high. And this is definitely not high. Now, in California heat, this may seem a little bit low, but remember, this is a test that's for the whole country. So I'm kind of more leaning towards, I don't think this system's undercharged either. If it was 97 degrees, these are too low, but 97 degrees is kind of an exception. So let's assume that it's 80 something in the summer. These numbers probably are more in line. I don't think it's undercharged. So just on this one alone, we're left with only one. The heater core is leaking into the evaporator core. Can someone explain how that may or may not make sense? Anybody? You make me call on somebody?
If heater core is leaking, that means that coolant's dripping from somewhere and the coolant's warm. So
Okay.
if it's hitting the evaporator, that's just stating the factor that the temperatures on the high side is going to be a little higher.
You're close. You're close. I'm gonna get you there the rest of the way. If your AC is blowing warm, the first thing you're gonna want to look at is your pressures, and you're expecting your pressures to be jacked up, because if your pressures are jacked up, it's not going to cause the forced condensing and the evaporation it's supposed to cause. But if your pressures aren't jacked up, something else is wrong. And we just verified these pressures are good. How can it still be blowing warm? Don't even look at the question. How could it still be blowing warm if our pressures are good? Give me a few options.
Something blocking the evaporator.
If something was blocking the evaporator, yeah, I guess that would have an effect. It could have some effect. If there's an airflow blocking the evaporator, the airflow is not going to make it to the customer. It's probably going to feel like it's blowing warm. In reality, it'd probably be blowing low volume of air, but the customer would probably call it blowing warm. What else? What if the evaporator is ice cold, but we're not diverting the air through the evaporator? Is it going to blow cold if it's being diverted the wrong way?
No.
So what do you think would be wrong with that car? Like what could cause the air not to be blown through the evaporator?
Because even if it wasn't blowing through it, it would still read right, but it wouldn't actually blow cold, right?
Ah, now you're onto it. This car has everything required to have a nice cold AC, but it's blowing warm. Why? Maybe, for example, the temperature door actuator is defective and it's stuck in the lukewarm position and it can't change over to send the air all through the evaporator. That could be a cause for this, given that's not a possible answer. What about if this had a heater control valve type system where the heater control valve should turn off, therefore cooling the heater core, but instead the heater control valve stuck open and the heater core is hot and the evaporator is cold and the result is lukewarm air, kind of warm. Couldn't that be this cause? See, these three would all cause jacked up pressures. The fact that the pressures are good means the actual refrigeration system is working well. Now think about why the heater core doing a PP of hot coolant onto the evaporator core would make the air blow warm. Why? PP. Is the evaporator going to cool the air if it's getting doused in hot coolant? No, that could be the problem. And you'd be like, this is so stupid, ASE. This would be like customer comes in complaining there's coolant running out of their HVAC box drain. And I'd say, I agree. But that's why I've always told you, better to eliminate, and then see if the last one makes sense. My answer is C. And I am correct. And you are fired. Now, so let me clear this. Drawing, clear all drawings. So with that, let's go back to the mouse. And how about, okay, we can do one electrical one. All right, refer to the HVAC blower diagram. Customer complains when it's in the fourth speed, the blower turns off. All right, we can look at this. When it's in the fourth speed, the blower turns off. You want to trace it? You can trace it. Do you guys remember electricity? Probably not. Not much. Let me do that same drawing thing. Spotlight. I haven't tried that. Leave that one. Spotlight. I don't think spotlights can work. I think it's gonna be draw. Okay, draw. Colors. Let's make a green ground, right? Now, what speed do you think we should draw this system in? We can draw different speeds, right? When's the problem occurring? Remember? In fourth, it turns off, right? So if it's turning off in fourth, we should probably just focus on drawing it in fourth, right? Okay, now let's go back to our plan. We're gonna draw it. I agree. And I did see that, Jesse. So nice pick. So here we go with a little slow on this whole drawing thing. I picked green. There we go. Green. Now, if we're in fourth, the ground would go here, here, here. Is that right? 1, 2, 3. Oh, nope. Sorry, I did that wrong. I did do that wrong. If you look again, oh, you know what? I actually kind of goofed that one. I think I did a bid one. I think I did bid one there, man. I'm gonna realize that my error's there, and then I'm gonna do still gonna do drawing. Let's say that this is fourth. Like this, like this, like this, this. So that's how it gets ground. You can see that, right? Now let's do the positive side. Okay. Actually, you guys can draw. Can't you draw? And Jesse, you're right. I realize that now. I think I meant for it to be 3. So that was Mobby. I meant to say 3. I read it wrong. Quite confident. Give me a volunteer. Anybody? No volunteers? You gonna make me pick somebody?
I got you, bro.
Try to draw. Try to see if you can do a ground right here. Let's do a test. Isn't this gonna be ground?
But you want me to draw that?
Yeah, if you go on your bar, you should see draw, and then you should be able to go to a little line. There's a little squiggle, and you should be able to make it green. Let's just see if you can do that. Otherwise, I'm gonna do it too. I want to see if you can do it. Never tried that before. This is me. But Edwin, as soon as you get ready, let me know. So if I do this as ground, what's that going to cause right here? What's that going to cause this relay to do? Can you guys see it? Who knows?
Open or close?
Yeah. Define open or close. Which one?
It would close it, so
Close.
it would bridge it pretty much at closing it.
Exactly. So as soon as this is magnetized, it's going to pull this over to here, which means now voltage will go through. So that blower motor should have voltage, right? We agree? And it does have ground, so this blower motor should be running. Now, let's take a little peek at something. If we had X open, what would that cause?
The motor not to work
When?
all time.
All time because it's
Exactly. It just wouldn't work. What was the customer's complaint?
Only in speed 4.
All right, what happens if we had a problem on Z?
Nothing would work.
Yeah, never. So our focus, even though I did make an error, 4 actually should have been over here. I need to redo the question. Our focus should probably be on Y, wouldn't you say? Now, again, if we go back down, this is going to mess up our highlighting. If we go back down, a short to ground at Z, let's break that down. If it's shorted to ground at Z, what do you think would happen? Short to ground at Z. Doesn't that blow the fuse?
So
A short to ground on the ground causes what? Nothing. Because it's grounded. So we brought it from being grounded to being grounded. Yeah, okay. How about open circuit on X? What's an open circuit on X cause?
Nothing would work. for the
It would never
blower.
work at all. What's a short to ground on? Did I list that twice? A short to ground on point Z again? Okay. How about an open circuit on point Y?
It would make that one section on the resistor an op.
It wouldn't work on just that speed. Now, given, I admit to you, I should have made it on third. That's a mistake. Because you can see, right? Zero's open, one is this resistor, two is this resistor, three is this resistor. I saw the 4 and I thought 4 was this path. 4 is actually a bypass. That was my beat. But you guys understand? This question requires no knowledge of air conditioning at all whatsoever. This question might as well get yanked off and shoved onto A6. Would you agree?
Yes.
Yeah, okay. But that's what you got to do. So that's another example. Let's do clear. Let's do, here's another one that doesn't require any diagrams or anything up here. All right, here's one. Actually, let's not do this one. This is more of an AC complaint without the gauges. How about this one? A seems to be experiencing a vehicle. Man, I found another error in my own thing. A vehicle seems to be experiencing problems with electronically controlled temperature door. Tell me, what's an electronically controlled temperature door?
It's a blend door, but automatically controlled.
Not necessarily automatically controlled. Close. What makes this door move? Is it the slider with the cable?
It's electric. It's an electric. So it's not mechanical. It's pretty much.
Yeah, it just means it's got an actuator. Yeah, it's an actuator. It's not a cable controlled one. Okay. Tech A says it can be tested with a DMM. What do you think?
C.
I'd hope so. Oh, your answer C? C is incorrect. Oh, you mean yes? Then I do agree. Tech B says it can be tested with a test light. All right. Compare, contrast. Tell me why yes or no.
I would say no because you'd use a test light to see if there's voltage, right?
Yes, but I want to make sure that I understand, that I explain well the problem with the test light. Who thinks they know the resistance of a test light? Anybody?
Isn't it very minimal?
Yeah, it might be like 4 ohms or something. So if we were to go to, let's say, this one. Cool. So if we go to this one and we were to go here and we were to put our test light right here. In fact, I can do it with this. Put our test light in right there. And then, in fact, let me redo that. Let's make it like this. Shoot our test light in right there. Now you'd be basically taking, let me pick even a different spot. Let's go with test light here. And then your other end of the test light, by the way, is grounded. We agree with that, right? Your test light's right here. And then the other end of your test light is grounded. And then right here, you got your basic light bulb. Look at what you just did. This little 5-volt reference should have to go through a very high resistance sensor. And instead it's like, oh, 5 volts? Yeah, I'll send you right up this way through only 4 ohms to ground. If you decrease the resistance from, let's say, 1,000 ohms, 1,000 ohms is what's normal, to 4 ohms, what would you do to the amperage, to the current in the system?
It would decrease.
If you go from 1,000 ohms of resistance to only 4 ohms of resistance, it's a lot less resistance.
Faster flow.
You basically go from like, think of ohms as obstructions. You go from a freeway with 1,000 obstructions to only 4 obstructions. You gonna speed up or slow down?
Yeah, speed up.
You know, speed your booty up. And
Pop-
you're used to doing like 23 milliamps or something. Instead, you're like, oh crap, look at this. Yeah, how about like 7 amps? You know what happens with 7 amps on this tiny circuitry?
Blows it.
It lets the magic smoke out. Those computers work on magic smoke. You know how I know? Because when the smoke comes out, it don't work no more. Because it was magic.
That's pretty impressive.
Picking up what I'm putting down?
Kind of magic.
Yes, sir.
Of course you are. So you basically give it an alternative path to ground using a test light. Anything with computers is a freaking no. It's just a no, because you're going to give it an easy path to ground. When you give it an easy path to ground, you run up the amperage. You have the amperage, little things let the magic smoke out of them. That's what happens. So test light's a no. No. So you guys saw me use that power probe. That power probe is high impedance. It's no different than a meter. It's really more of a meter than a test light. High impedance means your meter is going to have like 10,000 internal ohms or something. A lot of ohms. So that doesn't give an alternative path to ground that's going to cause an increase in amperage current. You know what I'm saying? Now, with that being said, I don't remember what number that was, but A is correct with the DMM and B is incorrect about the test light. A only. So these are the types of questions you're going to see. Lots of that type of stuff. Okay, now with that, there's still some stuff to cover, but in the meantime, we're going to get into that automatic temperature control, which is a Toyota specific unit. So you'll notice there was not really any chapter on that. It's kind of in a chapter, but not really specifically. Toyota likes to separate them totally like completely separate. I kind of see them as together but different, but Toyota has them totally separate. So we're going to jump into this Toyota presentation. Let's go with the basic AC controls first, which we talked about, but again, we were using the HVAC box that whatever day it was. I think it was Tuesday, actually. It was Tuesday after 4th of July. So if we're looking at this system, we got a blower motor. What do you think the air inlet, what would we call the air inlet if it was me talking? I tend to call stuff what I call stuff. Air inlet control, AKA
The door.
what door?
Blend.
Landor?
No. Blend door's temperature
Oh yeah, you're right.
only.
Lower speed door.
Air inlet control, but if it was me, I'd call it
Recirculating.
oh yeah. So recirculate either opens up for fresh air or closes up to pull recirculating air. Yeah. ASE is recirculate. Toyota may be calling it air inlet control. That's fine, but Toyota does tend to want to use their own terminologies. Temperature control, you can see. How does this temperature control door work? Thomas, pick somebody.
I'll pick Ruandels.
Ruendel.
Howdy.
Rudy. Describe it. How does it change hot to cold? Ruendi, I'll give you a clue. This right here is the evaporator core. And this right here is the heater core. So if you want cold air, where would you send the air?
Heater core.
You want cold air, you're gonna send it to the heater core
Oh,
that's hot?
I heard you wrong, brother. My bad. To the
That's all right.
evaporator.
So this is what's cool about the system. If the door is in this position right here, the air goes through the heater core, then the evaporator core. The evaporator core is not gonna be cold if the AC's off. So if the AC's off and the heater core is hot, that would be hot air. If we move the door up to this position, we don't let it go through the heater core. We let it only go through the evaporator core. And if the evaporator core, if the AC's on, the evaporator core will be cold, the air would be cold. It actually goes the other way. I was showing you the wrong way. It goes left to right. But you understand the concept, right? Randy, nice job. Pick somebody new.
Edwin Diaz.
Edwin, wow, it's just like the Toyota Place crew here. So if we pull air in here and it goes past all this stuff, how would we make the air come out on defrost and feet? What would we do to this? Edwin, what you think?
The door for that.
Close which one?
You close the middle one and then the bottom one for the defrost.
All right, if we close the middle one, the face vents go away and it would be on defrost and feet. But if you want it all on defrost, you could close the middle one and the lower one. If you want it on face vents and floor vents, you'd only close the defrost one. See, so we can have a whole bunch of different arrangements there. So if you think about it, there's three main doors. There's the recirculate, there's the temperature, and then there's the mode. And the mode changes where the air flows to do its thing. Whether it's warm or cold, this just changes where the air hits you. And then we got compressor control. So that's your basic piece. If we make it go through the heater core, it's generally going to be hot. But remember, this is one with a heater control valve. If it's a heater control valve, we can close it off. If it's a heater control valve, we won't have a temperature door. We don't need a temperature door. Our temperature control is the valve itself. If we close the valve off, what happens to the temperature in the heater core?
It gets cooler.
Exactly. And that's what we do if we move the temperature slider to the blue. And then if we want it warmer, we move the temperature slider to the red. What's it going to do for this heater control valve?
It's gonna open it up and let it in.
Which is going to make it hotter. So that's how we control heat on this type. This type controls the airflow. This type controls the coolant flow. They won't be both. It'll be one or the other. Yeah. So there's a lot of this, systems. This is the air mix servo motor, AKA a lot of times we'll call them actuator. The AC ECU controls it. Very good. The blower motor, a dual plane blower motor, higher airflow. We got a blower transistor with duty cycle. We do have some that actually have the integrated control circuits. And then we have other ones that are separate. The way we diagnose them is not really all that different. If you look at this one, this blower motor, what do you think the voltage is going to be on terminal 3?
12.6.
Yeah, source. And what about on 1?
0.
What do you think on 2?
5.
Whatever the switch is on for the. So like if it's like on level 2, maybe 4.
Okay, I'll give you a clue. FET, what's that stand for?
Feet.
Field effect transistor.
5.
And what do transistors usually get? They don't give voltage.
6.
We control them with either 12 or 0, 12 or 0, 12 or 0, 12 or 0. We call that?
And
Huh? When you get up and you go to the bathroom at the same time every day? Oh, duty cycle. Oh, not duty cycle, duty cycle. Oh, I got you. Okay. Duty cycle, pulse, 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 pulse. So if you see something like this is just getting a duty cycle. You're not going to get the meter out on this. You're going to, well, you could. It's hard to read duty cycle on the meter. I couldn't even figure it out on the fluke the other day. But this is probably more, what? What would you be your go-to tool to measure on two?
Scope.
Pico, pico, correct. Whereas this one, as you can see, this blower motor is going to get voltage, ground. Actually, this one has a separate blower motor controller. This blower motor has two wires, 1 and 2. And if you look, 2 is getting voltage and 1 is getting a varying amount of ground due to this being a controller, which is essentially going to be more of a blower resistor. So they have two different ones. This one has a blower resistor or a transistor that's separate. And this one has one that's integrated. So there can be varying things. You guys know about air filtration? You're hired. You can go ahead and do that. Plasma cutter generator electronically cleans the air. I don't see these very commonly, but they do exist. If you ever read about it, it's kind of neat. There's even a little bit more information in the textbook. So it takes water and oxygen molecules from the air and produces a positive and negative ions which circulate and help reduce airborne germs. Yeah, that's the deal. Toyota does some weird Japanese crap stuff. Beautiful things, I mean. So this system is automatic temperature control. You set it to 72, it does its thing. There's a little bit of an in-between. Some of them would do temperature control only. Other will do full-on automatic everything. Ramp the fan, turn the AC on, turn the AC off. They'll do everything fully automatic. Not to be confused with a fully semi-automatic assault weapon. Slightly different. So here's all the different modes that we can do. We could do all sorts of different things. You can put on bi-level, face, foot and defrost. They also vary the amount of volume on each one. So it's pretty fun. And again, here's a diagram. I feel like these get a little bit excessive where it's like a lot of stuff to follow, but this has the defrost, the foot, the face vents, all these multiple doors, and all these multiple doors will be controlled by actuators. There'll definitely be a temperature door actuator, which they call the air mix blend door. There'll definitely be a recirculate door, which they call the air inlet, fresh air and recirculated air, right? And then if you look, D, E, F, G, and H are all part of more of the mode doors. So a lot of those stuff. And Toyota, by the way, doesn't call them doors. They call them dampers a lot of times. So some of the stuff gets a little silly. There are these other ones that are pretty crazy. They're not doors. They're actually more like little rollers with a film. So they'll call them a mode control film. And if you notice, if you're on the solid part, that's off. And if you're on the slotted part, that's on. So here's what that actually looks like. They literally pull these on and off and over to block air or allow air. Now, if they detach, now you're going to have airflow all the time. It's going to malfunction. I think that these membranes or these films are an insane idea, but I'm just one guy. So I'm not sure how often they're failing, but at least some. And so that's really the basics. Now into automatic. Let's chat about this. If you understand the basic manual, the automatic will come pretty easy. So we've obviously got the DLC now in the game. We got some more communicating modules. We may have an HVAC ECU. Now notice, sometimes the AC control assembly is the knobs and the module is in a different location. Who found that on one of their faults? Anybody? Oh yeah. So that'll trip you up. You'd have to dig in TIS a little bit. All right. Edwin, pick somebody. Or I will.
Go timing.
I did not hear what you just said.
Jaime or
Jaime.
Yeah.
I literally thought you just said Thai tea. Tripping. Jaime. The air mix control servo motor for the driver's side, is that an input, a process, or an output?
That's a process.
No. The only processor is the ACE ECU.
Oh.
Try again. Tell you what, let me give you a new one. AC room temperature sensor, input, processor, output.
Input.
It's an input. It's input. Why? Describe how you know it's an input.
Because it's a sense, like it's a sensor.
Exactly. So you do remember. So you guys know your senses, your sensors, your sensories are inputs to your tiny processors. An AC room temperature sensor senses what?
Temperature
Temperature? Where?
in the room.
Inside the cabin. Yeah, that's correct. Good. That's an input to the AC ECU. Jaime, pick somebody new.
Jonathan.
Yo,
Jonathan, what's a blower motor? Input, process, output.
mm,
Does the blower motor sense? Does the blower motor do work? Is it more of a nerve senses or is it more of a muscle output?
it's a muscle output.
I agree. So the input is a sensor and the output does work. So the blower motor is an output. Jonathan, pick somebody new.
Is Julio here or nah?
Julio Cito, I think so. I think I saw him on there somewhere.
I don't see him.
No, Julio? Julio. All right, pick somebody new.
Jimmy.
Jimmy Choo. All right. How about the AC pressure sensor? Input, process, output.
An input.
Definitely inputs. Pick somebody new.
Jose Martinez. The
Jose
other HB.
D. Martinez. What is the AC ECU? Jose D. Input, process, output, AC ECU. Dang, there we go. It's the processor. So now that we've covered that, let's look at AC room temperature input, AC ambient temperature sensor input. This is measuring inside, this is measuring outside. AC evaporator temperature is an input, AC pressure sensor is an input. All these are great inputs to know because they're all going to help the computer calculate what to do to make the customer comfortable. Ultimately, the most important thing is how the customer feels, but that's not just the room temperature. Sometimes you notice if you go outside and it's really warm outside and you set it to 68, in the car, 68 might not be cool enough. You might want it more like 60. Like you might want, if it's really hot outside, you're gonna want 60. There's a few different things that come into play there. One is you're probably gonna be getting some heat radiating from the roof and from the glass and stuff like that. So you're probably gonna wanna feel colder. So it is gonna run some calculations on the ambient temperature sensor, which is outside. Also, who notices that their AC's super cold during the day, but then when you get ready to go home and it's kind of dark out, it's like too cold? You ever notice that? I know somebody does. That may be because the solar sensor. So remember, the solar sensor is measuring the amount of light. Why would that have an indication of how the customer feels? Anybody think they can break it down for me? Jose, pick somebody new. Jose D. Sacrosito. Why would the amount of sun change how the customer feels? It's got to do with physics. Close. I mean, basically, you're right. It's nice. Basically, you're right. It really comes back to that radiation part. You remember how the sun can warm your body directly through radiation? So even though, you know, the outside may not be as warm, because, and we're measuring that by the ambient temperature sensor, the actual radiation coming through the windshield might be making you warmer. So the AC ECU is going to run a calculation. How much sunlight's coming through? What's the outside temperature? What's the inside temperature? And then that can help it predict what temperature it should blow air. Also, it's going to look at, hey, how cold is our evaporator right now? If our evaporator is really cold, it might not need to move as much air, or it might start to blend a little bit of heat into the air to make it not so frigid. See, so this whole system looks at a lot of factors. In a way, you do too. If you jump into your pile of crap hoopty and you want AC, you might blast it, you might turn it down, you might turn it towards the heat a little bit, you might recirculate it. It all depends on how you feel. But we're trying to get a computer to do it for the customer, so the customer doesn't have to push buttons and turn knobs. You understand? We're basically trying to duplicate what the customer would do without having them have to do it. We're just trying to do it with the computer. So now with that being said, the AC ECU can control on the output, the AC solenoid, the blower motor, the rear defogger relay. It can control all those. Now, why is it that these things aren't showing inputs or outputs? And that'd be Sacramento, pick a name. You could unmute. It's a lot easier than take. Oh, fine. There you go. Kenny, why are these not listed as inputs or outputs? Notice the inputs point in and the outputs point out. Why are these four purple things not inputs or outputs? Or are they? Kenny. Bingo. You're there. They're not quite communicating, but you're close. So look, if you think about that actuator, 3 wires are a sensor. That's an input. But what are the other 2 wires? Kenny, pick somebody new. Adrian, what are the other 2 wires? Exactly, because they're the motor, right? 3 wires measure the position and 2 wires move the motor. So therefore, all those servo motors, AKA the actuators, Those are both inputs and outputs. 3 wires as an input, 2 wires as an outputs. They're both. All right, Adrian, pick somebody new. Let me guess. Jesse. Am I right? Yep. So Jesse, then what's this dark line? Yes, sir. Sir, yes, sir. What's this dark black line? A big wire? A double wire? Close. In this case, it's actually Lin, but basically that's a perfect answer. It's a communications line. CAN is faster. Lin is kind of old school, slower. It didn't need to be CAN. CAN is like high priority. This is sort of like, look, it's just the AC system. It doesn't have to be that fast. We don't need to have fiber optic. Let's just do dial up. Dial up's close enough. AOL 4.0. Now you're paying attention. So the AC control assembly is a module that sends signals on the LIN line to another module, which is the AC ECU. Not that bad, right? Now, with that being said, let's continue. So it can play around with programming. So if you look into the programming, it's going to write whole tables of what do I do with this temperature outside, this temperature inside, this much sun. I should move the temperature door to here. I should move the blower motor up to this speed, down to that speed. You know, it's like, it's going to run a lot of programs, and the programs are put in by Jesse. Who are the programs installed by or designed by? Engineers. Good. Now pick somebody new. Alexis. Nice. What do you got, the Mike Tyson? You doing the Mike Tyson? All right, so with that being said, here you can see we got a few different controls. Sometimes, by the way, the ECM actually controls the compressor. See, compressor and magnetic clutch controls for a 2GR is pretty typical. Here's some of the components we're looking at. In the box, we've all had a box apart now. Here is a more basic system where we're varying a resistor, and this varying resistor is going to come up with a resistance, and that's gonna send it through LIN to the ECU, and the ECU is going to move the actuator. But this right here is like some of the most early kind of jankiest auto HVAC. That's why you see, as soon as you see the numbers, you know it's auto HVAC. But what's more common would be more like something like this or this, where you actually get to set the number. This one's somewhere. I don't actually see the number on this one. And this would be the temperature. And yeah, they may even have an auto button, or some of them default to auto unless you manually change it. So it'll stay on auto, but if you want the fan up, you can turn the fan up and it'll just let you do it. So these are all examples of how the auto works. If you put it on auto, the earlier system, like this one right here, would do automatic temperature door control only. It would not ramp up the blower speed or lower the blower speed. It would not mess around with the recirculate door. It would just do automatic temperature blend control only. That's it. The more sophisticated systems down here, like even this one, this will do automatic temperature control, but it will also change the blower fan automatically. And it may even change the mode automatically to meet the expected demands based on the engineer's programming. Like that. Know what I'm saying? Picking up what I'm putting down. Now, why do we have two of these knobs? Why do we have two of these buttons right here? Oh, Alexis, what you think? What is this system?
It has dual temperature control, so the passenger side and
Yeah,
driver's side.
exactly. Dual zone, Hefe. So if we go way back to here, this is a dual zone. We've got an evaporator right here, and we've got the driver's side membrane and the passenger side membrane. And we can have evaporator here and no evaporator here. We could have full evaporator here and half evaporator here. This would be full cold and this would be kind of half and half. Exactly. So this is a dual zone and they have two different actuators and one can fail in one bad position. The other one works well still. So pretty neat. So this is more about thermistors. So actually, I'm going to tell you one really cool story that'll help you understand. I'm quite sure that I didn't tell you this, but I had a vehicle. I don't even remember what it was, to be honest with you, but it was the customer's complaint was the AC blows warm. Shocking. I put my temp gauge in there. I turned it to max cold. I turned the temperature all the way down. I blasted the fan. Sucker was blowing like 42 degrees. I'm like, you're crazy. So I talked with the service advisor. Hey, I got nothing on this. Can you ask if there's more? I mean, they have anything more info? Because it's blowing like freezing ice cold. And they said, oh, well, yeah, they told me it's really more like the automatic HVAC. When they set it to like 68, it feels like it's like 72 or 75 to them. It doesn't feel cold enough. They think that the temperature is out of calibration. So I said, okay, cool. It could be out of calibration. How do you think you check to see if the temperature is in or out of calibration? Alexis, you're still up. What do you think? I'm going to leave my pointer at a clue.
So what am I answering again? Like, what was the question?
How do you think you check to see if the temperature was calibrated or out of calibration? The customer had it in their mind that they're out of calibration, like a thermostat that's reading wrong kind of thing.
You would just get a thermostat and measure it to see if it's matching up or not.
Against what? How would you know what this sensor's reading?
Oh, it doesn't tell you. It's not one of those ones that have tell you the temperature on there.
You can't go by what it says on the screen because what it says on the screen is typically more of the setting. So how would you access that sensor's information?
TIS.
Close. I think I know what you meant, but you said TIS. How would you see what it's reading live?
The data list, live data.
Bingo, that's what I'm talking about. So you'd go ahead and you'd read that and you'd be like, oh, okay, let me compare it to a temp. You know what? And I found they looked fine. So I'm like, well, it's not the thermistor because thermistors can end up skewed. And I was kind of looking into it. What type of other things might cause it to blow a little bit too warm? Anybody now? This is open discussion. Why could it blow a little too warm? Maybe the AC pressures, I checked them, they were good. Remember, it blew 42 degrees. It's only on auto. I'll give you a clue. I backed the car outside and it did seem like it didn't blow cold enough. But then I pulled it inside and it was like, holy crap, this thing's blowing pretty cold. But outside, it didn't blow as cold, and inside it seemed to blow like maybe even colder than it needed to. Not reading temperature correctly is a good idea, Jay Bonnie, but we checked that with the scan tool and it matched up to the thermometer. So we've eliminated that.
What if it's getting it mixed up?
What if it's getting what?
Like mixed up, like it's reading a temperature, but it's not exactly that temperature.
Then again, we would look at the actual temperature on live data on the data list, and then we would compare it to the reading, and they were reading good. Christian, what are you thinking about the solar sensor?
It's faulty.
Why? Well, I mean, tell me why you think that would even have an effect.
So it's probably reading too much light or not enough light.
All right. If it was reading too much light, if there's a lot of light, what's it going to cause the AC temperature to do automatically?
Blow colder?
Exactly, but it's not blowing colder, is it?
No.
blowing too warm, right? So what might the sensor be reading? You're on it, just the other way.
Not enough light.
What do you think the system would do if it thought it was dark all the time? It'd probably blow a little warmer, wouldn't it? Because it's like, hey, there's no radiation. We don't need it that cold. You don't want your AC that cold when it's dark out, do you? I think so. So I went to go look into that temperature, into that solar sensor. And I don't remember the voltage, but it would give you a reading for light and dark. And you know what I found it reading? Dark all the time. And so what do you think my next steps would be? Anybody? Matter of fact, I remember this one now.
Where is the AC solar sensor located?
Okay, this I just remembered the vehicle now. It was on a really nice Suburban, like a fully loaded Suburban, and the ACE and the ambient light sensor, which they would call it, or the solar sensor, is located on the dashboard, right beneath the windshield. Think we should probably look at it, huh? Maybe take a visual look.
They had a cover on it.
They had the freaking dashboard cover, and they should have bought the one with the automatic temperature control option, but the one without automatic temperature control was cheaper. So they bought the automatic temperature control, which had no hole cut out in the freaking dash mat. So the whole thing was showing in the dark all the time. Is that ridiculous or what?
So say people with front window tint, like on like their front windshield, would they also have the similar issue since it's like blocking out the sun?
I think it could, depending on the type of tint. So if it's reducing the UV rays that actually trigger the sensor, it might potentially have an effect, yes. Again, like if it came in with this type of a problem, look at your surroundings. That's what I didn't learn in school. I learned in school, check voltage, you get the DMM, whip out the highlighters, the pencils, and it was sort of like, I spun my tires on this job for a while and I learned a lot. I'm like, man, rather than getting all technical, look around and see if anything a little bit more obvious jumps out. I had another similar one, it was on a Kia actually. Do you know what they had piled up over top of their solar sensor? Take a guess.
Stuffed animals.
Did I tell you this story?
No, that's just a common problem with Kias.
Dang beanie babies, man. They had they freaking beanie babies. All kind of beanie babies all over the beanie baby and piling the beanie babies all over. Yep, 100%. You were pretty close. I mean, beanie babies, man. Not just stuffed animals, collectible beanie babies. Yeah, just like that. So consider these things when we're talking about automatic temperature control. Think about if the sensor would cause it, how you can check the sensor to qualify it, to see if it's good or bad. So temperature sensors to me are easy. Access the sensor, measure the area of the sensor, compare it to live data, and boom. Now here's the problem. If you go to access the sensor and compare it on live data, if there is no live data, the way we used to have to do it, we'd look up the chart, right? And if it was reading 68 degrees, if it was actually 68 degrees, you'd follow this chart, and that should be measuring basically between 2,000 and 3,000 ohms. So you'd have to actually access it and put your ohm meter on there to measure the sensor. So ideally live data on that text stream, but if not accessible, you may have to bust your meter out and compare it to this chart. Okay, now who's ready to learn about refrigerators?
Brr.
Already. So if you can understand this type of baloney, you can fix some stuff. And that's another thing I didn't learn in school is like, I work on cars. And then I realized, hey, I've learned a lot of stuff about cars and I can apply it to anything and everything I ever touch. So when we first moved, we bought our first house, we didn't have no nice refrigerator. You know how much a nice stainless steel Samsung refrigerator with ice maker and all that stuff goes for? Anybody know actually?
$400.
How much?
$3,000.
1,200?
Man, like 2,400 bucks, 2,000, 2,200, 2,500. They're money. Like, and I found one, $800, brand new, on Craigslist. Little scratch and dent action. And I looked at it like, man, this thing's like perfect. What's the deal? Now, just think about that. People who are buying and selling stuff on Craigslist like that probably are not the most reputable folk out there. Okay. But I saw it, I liked it, I had to have it, I bought it. And it seemed fine, but I did notice milk would only last like 4 days. I was kind of like, I don't know, that's weird. Usually milk lasts a week. I looked on the screen and it said that the refrigerator was 34, but the milk was going bad. How would I test that reading against reality? It says it's 34 in the refrigerator. What could I do to test that? Put the dang thermometer in there. It was like 55, dude. It wasn't even that cool. Like 50, I think it might even been 60. Like, oh, that's why the milk is going bad. And so I proceeded to troubleshoot it. Any temperature sensor is just going to be a thermistor. Thermistor is 2 wires. This is the thermistor. If you just disconnect it and measure the resistance of the actual sensor, you would compare it to a chart. Luckily, I was able to get Samsung service info. And basically, I looked on the chart. I measured in there. It was like 60 degrees. It should have been, I don't remember, some amount of ohms. It was a totally different amount of ohms. So what it was reading was like 36. That was 6,000 ohms. The problem was it was reading 6,000 ohms when the actual temperature was more like 60. So the sensor was skewed. It was inaccurate. So what do you think the fix is? Sensor's reading skewed. What's the fix?
New sensor?
Yeah, it was 20 bucks. I bought a refrigerator for 800 bucks that these people couldn't figure out. So they sold it as a fake, new scratch and dent, when in reality it had a bad thermistor. It was $20. So see, like, just trying to say, the way that you go about troubleshooting is not specific to cars. If you think you know what's wrong and you can test it and you can come up with a diagnostic path, y'all are the future. You can fix anything. You could practically do miracles.
My parents' relationship?
You can restore your parents' relationship. Oh, I don't know if you can fix that one. No. You could almost do miracles. You can fix other stuff. People problems, I don't work on those. Technical stuff, I'm all about it. Whatever. I'll work on whatever, and I'll save a ton of money, and I'll stretch out a blue collar automotive income to be more comparable to some doctor's income, because I could do everything way cheaper. I end up doing a lot of work. It's all good. It does help. So there's that room temperature sensor. You'll notice they don't just hang it out in the middle of nowhere. A lot of times they'll put it behind a little vent, and it'll allow interior air to come through and hit it. That way it's not so raw. So like if that temperature sensor was out in the open, any currents, you ever feel like you're in the car and there's like cold air right here, but warm air right there? But if you were to re-angle the vent and all of a sudden the cold air were to hit the temperature sensor directly, it might throw off the whole cabin. They don't want that. So they'll bury it somewhere so no blowing air blows right in there and screws up the reading. It's supposed to be a little more of an accurate average measurement when it's in this tube. So they'll call this a lot of time an aspirator tube. Remember that, aspirator tube. It breathes the air to check the temperature. There's the outside temperature, maybe behind the bumper cover, maybe the grill, somewhere along there. It's pretty interesting. They also actually sometimes look at vehicle speed to anticipate wind chill for temperature, especially heat. Here's that ambient light sensor, or they'll call it the solar sensor. It's really a photodiode. Nice job. They do sometimes have duct sensors that measure the actual temperature on the dual zones sometimes. Again, thermistors. This is a thermistor, this is a thermistor. Pretty good. This is not a thermistor. This is a thermistor, and this is a humidity sensing resistance film. And I gotta tell you, don't really know a ton about how those work, but if I needed to, I would have to read it on TIS. And there's those air mix motors, AKA the servos, AKA actuators. Now, remember we were talking about how there's 5 wires. Count them up. 1, 2, 3, 4, 5. What did okay, we just had, who went last? I lost track. Might be.
Me.
Alexis, pick somebody new.
Christian.
Christian, what do these 2 wires do right here?
Power and ground,
Yeah, for what reason?
motor,
To move the motor, and the motor moves the door, right? So this is the actuator. Motor moves the door. Pick somebody new.
Alexis,
He already picked him. He picked you.
Molly,
Molly, what is the purpose of the 3 wires over here? Oops. 3 wires over here.
Would it be to control the level
But
of
that,
building?
you don't sound like Molly.
Well, she's not here.
Well, I'm giving her a fair chance. I knew I'd catch somebody eventually.
Take back my.
Christian, pick somebody new. All right, Ruendi, I guess you get it. Tell me
No,
what you,
I don't understand.
oh, you don't want it anymore? You wanted it, but now you don't.
No, okay, I got you, bro. It controls the level of the motor.
Close. It doesn't control. It
Well,
senses
because the variable resistor goes based off like,
position.
yes.
Exactly. Now, let's break this down. The motor just moves this way or this way. But how does the actuator know where the door is? Because this is its position sensor. So we're going to do a little drawing right here. We're going to do a drawing today. We're going to do drawing. So let's do draw and let's do red. All right, this, in fact, I have to look at this. I think this is going to be 5 volts. Cool. And this is the reference. We basically send 5 volts. Next, this one is going to be ground. Okay, who thinks they know what that other piece of crap is?
You mean the turd that's brown?
Yeah, the brown cerote.
Wouldn't that be the wire on the resistor that would pretty much signal what the voltage is going to be?
Yeah, exactly. We might call it the signal. So if the motor turned all the way clockwise, maybe it would read something like 4.5. If the motor turned all the way counterclockwise, maybe it reads something like 0.5. If the door was dead center, half hot, half cold, what do you think the voltage would be?
6.
It can only go to 5.
Oh, awkward. 2.5. Sorry.
Daddy. But that's also why we do a 5-volt reference. We don't typically use 12-volt references. This operates on 12 volts and ground, or ground and 12 volts. But sensors typically, they just do 5 volts. They like 5 volts. So with that being said, if full cold is 4.5 and full hot is 0.5. This will indicate position. So if we wanted to get it to be colder, which way would we move it? Right or left? Colder would be, I did it the other way, didn't I? This way is colder over here.
Yes.
All right. So if I needed it to be colder, I would move the motor maybe this direction, and that would bring the door towards colder. Boom. But then if the customer's like, oh, it's too cold, they move it a little bit more towards warmer. What would that make the motor do?
Go counterclockwise.
Go the other way. Go the other way. So actually what I should do is I should do a direction change. Let's go with colder is this. Move the motor this way. Warmer would be move the motor this way. Right? And its position would be constantly updated by this variable resistor, either going, let's say, down like this or up like this. It's going to be somewhere, you know, wherever the position is, it would be updated by voltage. So if you wanted full cold, maybe we do like 4.5. A little colder might be 4. Pretty cold be 3.5. Only slightly cold would be 3. Lukewarm air would be 2.5. Make sense? So if you're at 2.5 right now and you blast to full cold, this is going to say, hey, I'm at 2.5 volts. The controller is going to say, yeah, but the customer wants it cold. So let's start cranking that motor clockwise. It sends maybe 12 volts here and ground here. And the motor, and then as the motor, what happens to the 2.5 volts on the sensor?
Would it go up?
3.5. And then let's say that the customer is wanting it to be like pretty cold, but not the coldest. Maybe the target is 4. As soon as this reads 4.0, what's the controller going to do?
Stop.
Yeah, it's going to take away the 12 volts. Stop the 12 volts. And then what's the motor do?
The motor just stops.
That's it. Boom. So let me help you understand. Larry, the guy in collision, he has a problem where when he moves his knob to full cold, he hears behind the dashboard clack, 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 clack. But if he moves it just one notch off of cold, it stops. Then if he moves it warmer, it's clack, 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 clack. But one notch off of cold, it makes no noise. I've explained it once, but who thinks they can explain it back to me? Why?
Isn't it because I'm trying to remember the actuator?
Yeah,
Grinding like the teeth because they're plastic. They pretty much sheared themselves to death.
correct. But why does it stop then when we're at one notch off of full cold?
Because there's teeth on that section.
Close. This motor has teeth all the way around. But the thing is, if we want basically almost full cold, that's at 4 volts. If this motor's stuck at 4 volts and this reads 4 volts and everything reads 4 volts, what's the controller tell the motor to do?
Turn off.
Turn off, and the clicking stops. But as soon as you try to set it to something other than 4 volts, if you say like go to 4.5, it tries to move the motor and it's stripped and it's like click, clack, crack, crack, click, clack, clack. Or if you try to turn it more warm, it tries to move the motor the other way and it's click, clack, crack, clack, crack, crack, crack. So basically the mechanism is stuck. The mechanism is stripped. The reason it stops at one particular position is because that particular position happens to match the location it's stuck at, and it turns the motor off and stops the clickety clacking. Super common, especially on domestics. Picked up all that, right? Everybody, that made sense to you? I'm sure it made absolute sense and I missed nobody. I'm sure. So there's like various control feedback. So we're looking at solar sensor coming in, all the temperature sensors coming in, the servo motor feedback, that's the 3-wire, and that's coming in, and it's all going to the AC amplifier. And the AC amplifier is going to do, various calculations. Now, I'm going to tell you straight up. Sometimes exactly what happens inside the ECU with logic gates and stuff like that, I'm out. For real. If you want to really know exactly how the ECU works with ones and zeros and how it makes logic, I'm not your guy. I don't know. I really don't. But part of the reason I don't know is because I don't need to know. And I try to focus on what I do need to know. So if you're looking at the practical application, we're going to be having the AC ECU with little various parts inside of it. Mostly what I need to know is if I get a code for, let's just say, this is a servo motor for the temperature door, how do I proceed with diag? Follow what I'm saying? How do I proceed with diag? If I say temperature door actuator, open circuit, or high resistance, or a lot of times what it'll say is like low voltage. You know what that means? That means I'm showing on the feedback circuit, I'm going to be showing something along the lines of 0 volts. It should never be 0 volts. Understand that. This one is 5, this one is 0. They design it so that even when maxed out down here, it'll still only be as low as 0.5. How could I be getting 0 volts on the brown? Anybody think they know?
You mean 0 volts or 0 point? But
0.0. It's full on 0.0 volts. How? Remember, this is only supposed to read 0.5 to 4.5. If I'm reading either 0 volts or 5 volts, that's going to set a code because it should never read that low or that high by design.
would it
It's
be a
reading
short to ground?
what'd you say?
A short to ground or open the system?
If it was a short to ground, that could do it. We could have pinched this wire to this wire, but that's not that likely. It's possible, but not likely. What's more likely?
An open,
Where?
right off of the brown wire, pretty much the entrance point.
Yeah, an open right here would cause it. But the open could be right here. If it's right there, what are we replacing?
If it's inside, we're replacing the whole entire sensor.
The
Yeah,
actual, yeah. What if it's outside?
Then you can replace the wire or resolder it.
How would you determine if it's inside or outside? So let me reword that. You guys will be good at understanding. It's an open, okay. But where? If it's in the actuator, we need an actuator. If it's in the harness, we need the harness repair. I need to know which one. You tell me, how would we know?
Visual inspection on the wiring.
All right, but the wiring's like a half a mile long. I'm not paying for that.
A ground or a voltage test from one pin to another.
All right, so if you were to measure 0 right here, and then you were to go up to the ECU and you were to measure, let's say 5 at the ECU, because the ECU may have some voltage left in it. If it's 0 down here and 5 here, where's the problem?
That wire.
So see, there'd be a voltage difference in the wire. It's kind of funny. Now, if you were to have 5 here and 5 down here, where's the open?
Then it would be the actuator.
Exactly. So that's how you'd need to get your meter out and actually check it. Okay, here's another thought. What if we had an open right here? What do you think that would make it read?
It would make it read like it's constantly just NOP.
Well, voltage. Talk to me in volts.
If there's an open on that, then if it's reading 0, then there'd be 0 volts coming into the actuator.
Right, and so it would read 0. So a lot of times we're going here and we're looking at the signal. And if the signal's 0, it's because either it lost its 5 volts or there's an open on the signal. Those are the two, right? If we lost 5 volts here, if we lost 5 volts here, that's going to read 0. If we lost a signal, that's going to read 0. Make sense? Okay, now let me switch it up so you can understand what I'm saying. If it was reading, let's just say 5 volts on the brown, what are your thoughts?
That's bad because shouldn't it be 12.6? Oh wait, the signal.
No, sensors, we like to use 5 volts.
5. My bad. So that's
That's
good.
okay. How could it be reading 5 volts though? It doesn't make any sense, man. Go on, dude.
The variable resistor be stuck on its maximum voltage.
It could be, but that's not realistic. You know what's pretty realistic? What would happen if we had an open ground?
It would screw life.
Yes. But what would it read?
5 volts all around.
Exactly. So if you get a code and it says short or high voltage, it's probably because you have a problem on the ground. Maybe internally the printed circuit opened. Maybe there's a loose connection at the pin. Maybe the wire's cut in half. Maybe the controller that's the source of the ground has failed. So we don't know if it's the controller up here or the wiring or the actual component. You need to be able to do voltage tests for that. Picking up what I'm putting down, kind of, sort of. That's your jam right there. So let me take you through what I would do. If you had a problem with one of these sensors or with one of these components, you could go here. And what do you think we should get on this one reading right here?
5.
Exactly. You should get 5.0. What should we get right here?
0.
0.0. That tells me this is good and this is good. It doesn't tell me anything about this or this or this. So a lot of times what we'll need to do is we'll go to this sensor and we'll check 5 and we'll check 0 and then we'll check this one. And if this one's reading, let's say 0.0, now I'm going to trip you out. You probably won't understand this, but I'm good with it. And I come in and I take a jumper wire. Okay, because remember, I do the flat radio mechanic style. I take my jumper wire and I jump 5 volts to here. What should it read?
0.
If I jump 5 volts to this one?
Or that should be 5, but shouldn't be canceled out by the ground.
But I'm not jumping the ground. I'm only jumping the 5. So see, this is what'll trip you out. If you don't want to get your meter and test all sorts of stuff, a lot of times you can look at the actual voltage on the text stream. And if you can find the voltage or the reading on the text stream, you could disconnect the sensor. You can jump the 5 volts to the signal and it should peg it one way. Then you can undo your jumper and jump the ground to the signal and it should peg it the other way. So if I jump it 5 volts to ground and it reads 5 volts, cool. And then if I jump it ground to signal and it reads 0 volts, that tells me this is good, this is good, this is good. All these wires are good. That tells me the actuator's bad. But you got to be like, you don't need to know that right now. You don't need to do that for your ASE. But if you can understand that concept, you'll be able to diagnose more quickly. That's kind of a trick. You know what I'm saying? Picking up what I'm putting down. If not, it's all right. In time. So, continuing. Understand a little bit how to do the diag. These will be on the diagrams. Overall, pretty good. This is more about the EWD than anything. So I think we're probably pretty good right there. Now, tomorrow we're going to start doing some diags. We're gonna also get back to doing some lectures while you're in class, okay? So we're gonna do diags together. As you saw, like one of the next thing, verifying the complaint, doing that type of stuff. So we are gonna jump into that. That's what we're working on. Everybody's gonna get to do a diag or more. You're gonna have to write a repair order on your diag. And we're gonna continue doing the theory of the diagnosis. So we got a pretty slammed week, so don't come in sleepy. We gotta make it happen. Okay? Anybody got any questions?
I have a question off topic.
Okay?
Do you know where the Borsar's office is?
The bursar's office is right across from where we get the food. Go get your,
Okay, yeah, because they told me they have a couple checks from the past semesters for me.
and I have no idea what their hours are. They're probably banker's hours. I would get there at 5 and head straight in.
Yeah, I was gonna get there like 4.
Yeah.
Okay, thank you.
So some tough stuff, but this, I definitely need you guys to dig in. We've really only got this week to do the work and we're learning, and then Monday for ASE prep. So don't start flaking out on me now. Definitely dig in and get this thing done. Some of these things are still to come, diagnosis, simulator, and whatever, but from that's automatic temperature control. I don't think it's that complicated, but from here out, we're on diag. So take your time, make sure you're caught up on assignments, make sure that you're up on the reading and you're ready, because the diag's gonna hit tomorrow like Fast and Furious style. Sound fair?
A question. So we have to do our A7 by next Friday, right? Or is that what because on
Yes,
premise
yes.
it says, yeah.
The only thing is the problem is they're kind of funny about when grades are due. So I'm gonna say, to be safe, I always used to say like a week after the last day. So the last day is 1 week from Monday. So if you did it within a week, you're probably good. But like I found last time, they all of a sudden snuck the due date closer. It's just because they want to spread their workload out. It's kind of frustrating. So sooner is better. There's no real reason you can't be ready for that ASE Tuesday, Wednesday, Thursday, Friday. Those are all good days. If you have to wait longer, but I don't really recommend it. Okay.
Also, is there a way you could send a link to the A4 stuff? Because I'm retaking my A4 on the 22nd.
Put it in the group chat and I'll send it.
Okay.
I had a question about last week.
It was a fine question. You guys, I give you anything I've got, it's yours. Other people, if they've taken the class previously, I give it to them. But I get people requesting access to that crap all the time. And it's just usually, I don't think so. So, but you guys, anything I got, what's mine is yours with regard to ASC prep. Yes. Hopefully you guys saw, you don't want to be up on stage and graduation being like, okay, you got 2 ASEs, because when everybody else like 7, 8, 9, 10 ASEs, and like 2, it's gonna come out.
Also,
Not
I'll put you on blast.
Yeah, he'll put you on blast. Not working anymore because of the thing and whatever. It's all gonna come out there. So make it happen. Oh, and I think we'll be eating pretty good the rest of this week, wouldn't you say?
Wouldn't the cake be bad by now?
No, it's in the fridge. But I'm talking about the spaghetti, dude.
Oh yeah.
Uh-huh.
I'm gonna be munching on that.
Beauty. All right, you guys take the studying stuff seriously. Don't let me down. Make it happen. If you need something, put on the group chat. Sound fair?
See.
Don't you wish you could be an AT9 and do lectures for 5 hours a day?
See.
You do, don't you?
Tell Heber and Eddie to fire up.
They're fired up, believe me.
Oh, I know.
Oh yeah.
All right,
Gravy.
have a good day, Mr. Kelly.
I'll catch you guys on the group chat if you need some.
A question. So you know how I had texted you about the Tacoma I'm bringing? Like, since it doesn't have the smart key, I should just be able to do it with the texture, right?
I don't know that procedure particularly well. Sometimes it's just start it with one key and then start it with the other key. But that information will for sure be on TIS. I will guarantee it. Just because you couldn't find, it might be in new car features somewhere. There will be information on how to do that key programming. And if there's literally no information anywhere, maybe the key doesn't need to be programmed, but like what you were saying, it's gonna need to be programmed. It might like, dude, sometimes it just start it with one key, take that key out, put it the other key and start it right away. And that's it. But you'd want to source that information specifically. You don't want me to go and source it for you. Because if you're looking for somebody to read to you, I'm not the guy. Somebody else might read you a story, maybe before bed. But I'm not the bedtime story guy. It's there, dude. Find it. Make it happen.
Okay. Well, I can't bring it in, right?
Great. It'll be in there. Dig it. Dig it. New car features is my bet. I'll bet you.
Thank you. Okay. Bye.
Any more relevant to AC preferred? Make it happen. Don't let me down.